Hello friends, welcome back to the channel. Caching is one of the most powerful techniques in modern systems. It makes applications faster, reduces database load, and improves user experience. Sounds amazing, right? But today we are going to learn something interesting. Sometimes, the same cache that improves performance can also create performance problems. And one of the most famous examples is Cache Stampede. By the end of this video, you will understand exactly why it happens, why engineers worry about it, and why this problem appears in real production systems. Let's begin. Before we understand Cache Stampede, we first need to understand one important concept: TTL, time to live. Imagine we cache a product price. Right now the price is $100. The cache stores that value. Everything looks fine. But what if tomorrow the price changes? Now the real price becomes $120. But the cache still contains $100. Users are now seeing incorrect information. That is a problem. So we cannot keep cache data forever. At some point, old data must disappear. That is why cache systems use TTL, time to live. When data is stored in cache, we can also tell the cache, keep this data for 5 minutes, or keep this data for 1 hour, or keep this data for 24 hours. When that time ends, the cache automatically removes the entry. Think of TTL like an expiry date on a food packet. Once the expiry date is reached, the item is removed. The same idea applies to cache. Now notice something important. TTL is not a problem. TTL is actually helping us. Without TTL, users might continue seeing old data forever. So cache expiration is normal, cache expiration is expected, and cache expiration is necessary. Now let's see what happens when TTL expires. Suppose a cache entry disappears. A user opens the product page. The backend checks cache. Nothing is found. This is called a cache miss. Since the data is missing, the backend goes to the database, fetches fresh data, stores it back in cache, and returns the response. Everything works correctly. Nothing bad happened. One cache miss is completely normal. In fact, every system experiences cache misses. The database handled the request. The cache got rebuilt. The user received the response. Life continues normally. So a cache miss is not the problem. Now let's ask an interesting question. What if the cache expires? And only one user arrives? No problem. We already saw that. But what if the cache expires? At the exact moment, thousands of users arrive. Now the story changes. Imagine a popular page. Maybe a trending product. Maybe a viral post. Maybe a live IPL score page. The cache expires. And at that exact moment, thousands of users request the same data. The first request checks cache. Nothing there. Cache miss. The second request checks cache, still nothing there. The third request, same result. The fourth request, same result. Very quickly, thousands of requests discover the same cache miss. Now let's think like the backend. The logic usually looks something like this. If cache is missing, get data from database, store it in cache, return the response. Nothing is wrong with this logic. The code is correct. The application is behaving correctly. So where is the problem? The problem is timing. Every request executes the same logic at the same moment. Nobody knows another request is already fetching the data. So everyone reaches the same conclusion. I should go to the database. And that is where things become dangerous. Now let's see what the database experiences. Imagine one cache miss. That creates one database query. Completely fine. Now imagine 10,000 requests discover the same cache miss together. Suddenly we get 10,000 database queries for the exact same data. Think about how wasteful that is. The first query would have been enough. But the database repeats the same work thousands of times. A single cache expiration creates thousands of database requests. Now the database starts feeling pressure. More queries arrive. More CPU work is required. More connections become busy. More memory is consumed. Response times become slower. the database starts becoming a bottleneck. And remember, users are not asking for different information. Everyone wants the same data, yet the database is forced to repeat the same work again and again and again. And this situation has a name: Cache Stampede. A large number of requests discover the same cache miss and rush toward the database simultaneously, just like a crowd rushing toward the same destination. The cache disappears, and everyone runs toward the database. That rush is called a cache stampede. And this is why engineers care so much about it. Cache stampede often appears during high traffic. Exactly when the system is already under pressure, the cache expires, traffic spikes, database load explodes, response times increase, and sometimes systems become unstable, all because one cache entry disappeared at the wrong time. So today we learned something important. We learned why TTL exists. We learned why cache expiration is necessary. We learned that a cache miss is completely normal. And we learned that the real danger appears when thousands of requests discover the same cache miss together. That creates request amplification. The database becomes overloaded. And that situation is called cache stampede. Now, a very important question appears. If cache stampede is such a common problem, how do real systems prevent it? Do they use locks? Do they merge requests together? Do they refresh cache differently? That is exactly what we will learn in the next video. Thank you for watching. See you in the next video, where we make another hard topic easy actually.